A pleasant day, students! Welcome to another episode here in Valenzuela Live Mathematics 8. I am Ms. Beverly N. Abulak from Vicente P. Trinidad National High School, and I will be your math teacher for today. Come in, let us explore and discover the beauty of mathematics. We are now on the third week of the second quarter, and together we will learn about relation and function. And for today's lesson, you should be able to illustrate a relation and a function, verifies if a given relation is a function, and determines dependent and independent variables. Are you ready? There are many occurrences in real life that can be better understood by observing how one quantity behaves in relation to other quantities. Let us begin this lesson by thinking about how two things or quantities relate to each other. What relation can be drawn between quantities? Let's connect. Direction. Use an arrow to connect each quantity in set A to the corresponding quantity in set B. Answer the questions that follow. Number 1. Mrs. Reyes is a dealer of poultry eggs. He sells them at 210 pesos per tray for large sizes of eggs. The following are the costs for each number of trays. Question. How is the cost related to the number of trays? How many quantities in A relate to each quantity in B? Number 2. Diana is cleaning the house. Help her to complete the task by drawing an arrow from set A to set B. Question. How the quantities in set A are related to the quantities in B? How many quantities in A relate to each quantity in B? Number 3. Given a number 6 in set A, which are its factors in set B? Question. How do you relate the elements in the two sets? Alright, let's check. In the previous activity, you were asked to connect the elements in set A to their related elements in set B. These are called the mapping of elements or quantities. In mappings, the arrows that connect elements of the two sets are said to be the correspondence of the elements. Below are the mapping of the correspondence illustrated in the previous activity. So in number 1, as you can see, the cost in pesos is related to the number of trays of eggs sold. In number 2, as you can see, the object in set A is related to its proper place in the house, which is on set B. And number 3, the given number in set A is related to its factors in set B. Now, have you got the same correct answer? Very good. The illustrations are examples of a relation. But what is a relation? A relation between two sets is any ordered pairs containing one object from each set. The elements in the first set, where the arrows came from, are called domain, while the elements of the second set, where the arrows end, are called range. The reason or rule that you follow to make this mapping is the relation of the two sets. A relation may be classified as one-to-one, many-to-one, or one-to-many. It is one-to-one relation if every element in the domain is mapped to a unique element in the range. Many to one if two or more elements in the domain are mapped to only one element in the range. One to many if each element in the domain is mapped to any two or more elements in the range. And a combination of a many to one relation and a one to many relation is called a many to many relation. In the previous activity, the relation between the numbers of trays of eggs to its cost is an example of a one-to-one correspondence. The relation between an object to its proper place is an example of a many-to-one correspondence, while the relation of a given number to its factors is an example of a one-to-many correspondence. Representations of relations. So aside from mapping, a relation may be represented in four other ways: a table, ordered pairs, graph, and equation. So we have the relation expressed in a table. The relationship between two variables can also be presented by a table. So the table below illustrates the relationship between the two quantities. As you can see, Mrs. Reyes is a dealer of poultry eggs. The table shows the costs for each number of trays. The number of trays of eggs, which represented by the X, and the costs in pesos, which represented by the Y, presented horizontally and vertically. Question: what is the cost of each tray of eggs? Very good, 210 pesos. How much would Mrs. Reyes receive if he sells 10 trays of eggs? 50 trays. Asam, Mrs. Reyes will receive 2,100 pesos for 10 trays of eggs. But how about 50 trays of eggs? Very good. She will receive 10,500 pesos. Last, what rule does he have in mind to arrive at this table of values? Correct. Multiply the number of trays by 210. Next, we have the relations expressed in ordered pairs. Based on the sample problem that you have encountered, the following ordered pairs were derived from the relationship between the number of trays and the total cost. Then the ordered pairs are quantity 1, 210, quantity 2, 420, quantity 3, 630, quantity 4, 840, and quantity 5, 1050. And in general as quantity X, Y. Next, we have the relations expressed as a rule or equation. A relation may also be presented through an equation in two variables or a certain rule expressed in the equation. Now, let us model the relationship of the total cost and the number of trays of eggs through the equation. So as you can see, the total cost is equal to the cost per tray of eggs multiplied by the number of trays. So if 210 is equal to 210 times the quantity of 1, 420 is equals to 210 times 2, 630 equals to 110 times 3, 840 equals to 110 times 4, 1050 is equals 210 times 5. Then y is equals to 210 times the quantity of x is the rule expressed through the equation in two variables. So using the existing rule, y is equals to 210x, we can determine the total cost of the numbers of trays of eggs sold. So the sets of values of x represents the domain, and the sets of values of y, which represent the total cost in pesos, represents the range. Next, we have the relation described graphically. So below is the graphical representation of the relationship described in the previous slide. So it illustrates the relationship between the total cost and the number of trays of eggs. The x-axis represents the number of trays of eggs, while the y-axis is the total cost in pesos. Relations that are functions. A function is a special type of relation. It is a relation where no element in the domain is mapped or paired to more than one element in the range. So going back to the types of relations, which of them can be called function? So by looking at the definition of a function, one-to-one relation and many-to-one relation are functions. And one-to-many and many-to-many relations are just mere relations. So let us examine the next examples by further understanding. Example number 1. Determine which of the following sets of ordered pairs is a function. In set A, we have quantity 3, 5, quantity 2, 7, quantity 4, 6, and quantity negative 3, negative 5. In set B, we have quantity 0, 1, quantity negative 1, 2, quantity 0, 3, quantity negative 2, 4, and quantity negative 1, 5. And in set C, we have quantity negative 1, 2, quantity 1, negative 2, quantity negative 2, 16, quantity positive 2, negative 16, quantity negative 3, negative 54, and quantity 3, positive 54. So as you have noticed, set A is a function. Since there are no distinct ordered pairs having the same first element. Next, set B is not a function. Since ordered pairs quantity 0, 1 and quantity 0, 3 have the same first element. How about the set C? Set C is an infinite set, but the pattern shows that there are no abscissas with the same value. So hence, set C is a function. The set of ordered pairs represent a function if no two distinct ordered pairs have the same abscissas. We have example number 2. A graph can be identified whether it is a function or a mean relation by using the vertical line test. So as you can see, the graph in A is a function. Since the vertical line touches the graph at exactly 1 point, even if it is moved to the right or to the left. The graph in B is not a function because if we examine the vertical line, it touches the graph more than once. Letter C. Examining the vertical line in graph C, it touches the graph once. Hence, the graph in C is a function. Vertical line test. This is a test that uses a vertical line to check whether the relation expressed in the graph is a function or not. If every vertical line intersects the graph not more than once, then the graph represents a function. Example number 3. Determine whether the given equation is a function or not. We have A, y is equals to 3x minus 2, B, y is equals x squared plus 1. For letter C, we have y squared equals x plus 1. For letter D, we have y cubed is equals x squared plus 2x. So to determine if a given equation is a function, let us assign a test value for x and substitute it to the given equation. If one value of the domain yields exactly a unique value in the range, then the equation represents a function, and otherwise, it is not a function. So let's have the solution. So for letter A, we have y is equals to 3x minus 2. Let us take x is equals 1. Substitute this value of x to y is equals 3x minus 2. Then we have y is equals 3 times the quantity 1 minus 2. Then we have y is equals 3 minus 2. Then y is equals 1. So the ordered pair is quantity 1, 1. There is only one value of y for one value of x. Therefore, y is equals 3x minus 2 is a function. Letter B, we have y is equals x squared plus 1. Now again, let us take x is equals 2. Then substitute this value of x to y is equals x squared plus 1. Then we have y is equals 2 times 2 plus 1. Then we have y is equals to 4 plus 1 and y is equals 5. So the ordered pair is quantity 2, positive 5. There is only one value of y for one value of x. So therefore, y is equals x squared plus 1 is a function. So for letter C, we have y squared is equals to x plus 1. Now let us take x is equals to 3, then substitute this value of x to the equation. So we have y squared is equals to 3 plus 1. Simplify, we have y squared is equals to 4. Then next, we have to extract the square root of both sides of the equation. So we have square root of y squared is equals to square root of 4. Then we have y is equals to square root of 4. Next, we have y is equals to positive negative 2. So the ordered pairs are quantity 3, 2 and quantity 3, negative 2. There are two values of y for one value of x. So therefore, y squared is equals to x plus 1 is not a function. Next, we have letter D. Y cubed is equals to x squared plus 2x. Let us take x is equals to 2. Then substitute this value of x to the equation. So we have y cubed is equals to 2 squared plus 2 times 2. Then we have to extract the cube root of both sides of the equation. Then we have y is equals to 2. So the ordered pair is quantity 2, positive 2. There is only one value of y for one value of x. So therefore, y cubed is equals to x squared plus 2x is a function. Take note, if one value of the domain yields exactly one unique value in the range, then the equation represents a function. But if a rule or an equation represents a function, then it can be written in the form of y is equals to f of x. The rule of function is also evident in some real-life relationships. For instance, the relationship of a child to his biological mother is a function since there is no child that has two or more biological mothers. The relation is one-to-one, thus a function. Example number 4. Tell whether the following real-life relationships are a function or a mere relation. So for letter A, we have the rule that exists between each person to the name of his or her brother. Function or mere relation. Very good. It is a mere relation since there are people who have two or more brothers. Hence, the rule which each person is paired to his or her brother is a mere relation. Next, the rule that exists between every person and to the name of his or her biological father. That's correct. It is a function. Every person has only one biological father. Therefore, the rule that every person relates to the name of his or her biological father is a one-to-one relation. Therefore, it is a function. Take note, all functions are relations, but some relations are not functions. Example number 5. We have y equals 2x plus 1. So given a table of values presented horizontally, to find the missing values of y, we have to substitute the given value of x in the equation. So if x is equals negative 1, substitute the given value of x in the given equation. Then we have y is equals to negative 1. If x is equals to 3, substitute the given value of x in the given equation. Then we have y is equals to 7. It indicates the relation between the independent variable x and the dependent variable y. The variable y is a dependent variable because its value depends on a real number assigned to x, which is an independent variable. Considering set B and set C below, the set of all abscissas in a relation is called the independent variable, and the set of all ordinates in a relation is called the dependent variable. Function notation. The function notation y is equals f of x, which is read as y equals f of x, or y is a function of x, is used to denote a functional relationship between x and y variables. If there is a rule relating y to x, such as y is equals 5x plus 2, and if the relation is a function, then you can also write this in function notation as f of x is equals to 5x plus 2. F of x represents the value of the function at x. The name of the function is f. The figure below shows the domain as the set of input values represented by x and the range as the set of the values of the function's output represented by f of x. To find f of x for a given value of x is to evaluate the function by substituting the value of x into the equation. For example, given the function f of x is equals to negative 2x plus 1, find f of 3 and f of negative 3. Solution: we have f of x is equals negative 2x plus 1. This is our function rule. Then substituting the value of x by 3. Then simplify by multiplying negative 2 and 3. Then by simplifying further, it results to negative 5. Therefore, f of 3 is equals to negative 5. Next, for letter B, we have the function rule f of x equals to negative 2x plus 1. So by substituting x by negative 3, we have f of negative 3 is equals to negative 2 times the quantity negative 3 plus 1. So by simplifying, we have f of negative 3 is equals to 6 plus 1. Then by simplifying further, it results to 7. Therefore, f of negative 3 is equals to 7. Now, is it clear? Alright, let's have another activity. Directions Choose the correct answer by clicking the corresponding reactions in each of the choices given. You have to press the heart react button if the answer is A. Then you have to press like react button if the answer is B. And wow react button if the answer is C. And haha react button if the answer is D. Are you ready? Question number 1. Given the mapping at the right, which sets of ordered pairs describe the mappings of elements in set A to B? Are you done pressing the correct react button? Very good. The answer is letter A. Therefore, you should be able to press the heart react button. Next, number 2. Which of the following sets of ordered pairs represent a function? Is it A, B, C, or D? Are you done pressing the correct react button? Awesome! The answer is letter A. We have quantity 0, 2, quantity 1, positive 3, quantity 2, 4, quantity 3, 5, and quantity 4, 6. Therefore, you should be able to press the heart react button. Next, question number 3. Which of the following rules represents a mere relation? A. Children and mother at home. B. The area of a circle and its radius. C. The amount of a company tax and its net profit. D. The salary of a worker and the number of hours rendered. Are you done pressing the correct react button? Awesome! The answer is letter D. Therefore, you should be able to press the haha react button. Next, question number 4. For the function quantity 4, 3, quantity 0, 6, quantity negative 1, negative 3, and the set quantity 3, 6, and negative 3 is called A. Domain, B. Function, C. Range, D. Relation. Are you done pressing the correct react button? Very good. The answer is letter C. Range. Therefore, you should be able to press the wow react button. Last item. Which of the following mapping illustrates a many-to-one correspondence? Is it A, B, C, or D? Again, take note. A mapping that illustrates a many-to-one correspondence. Alright, are you done pressing the correct react button? Very good. The answer is letter D. Therefore, you should be able to press the haha react button. Have you got the perfect score of 5? Very good. Now, let's watch and listen to the song entitled The Domain and Range Song. So in order for you to remember and appreciate our lesson for today.
input is the set of X, the output is the set of Y. And when you use the vertical line test, you always better know the reason why. With tables and graphs, diagrams, and equations like f of X. Set of input, this is the main. The set of outputs is the range. When no X repeats, you have a function. The set of input is the main. The set of output is the range. When no X repeats, you have a function. A function is a type of relation. A relation is not always a function. An input may have more than one output. An output may have more than one input. But when every X is exactly one Y, we give that special name a function. Set of input is the main. The set of output is the range. When no X repeats, you have a function. The set of input is the main. The set of output is the range. When no X repeats, you have a function. The set of input is the main. The set of output is the range. When no X repeats, you have a function. The set of input is the main. The set of output is the range. When no X repeats, you have a function.
Alright, for your homework, just take a screenshot or make a copy of your homework that will be flashed on the screen. Then solve and analyze the problems located on your self-learning module, page number 6. Again, this is Teacher Beverly Abulak, your mathematics teacher. Thanks for watching till our next virtual engagement.